Hello. All right. So just a little bit about me. Klarna was actually my first professional software engineering job. Everything before that was rather academic research related to functional programming, particularly statically typed functional languages like standard ML. I came to Klarna in 2011, and so at that time I was on what they called then the core team. If you were at Mike Williams' talk this morning, that was roughly the chimpanzee phase of this Fred project. Currently, I'm on the real-time core platform team, which would be one of the tiger teams of this project, for that analogy. And my interests are eating out and cooking very, very large pieces of meat for people who coincidentally have joined my team in the past 3-4 months. I don't think that's at all related. Klarna, I'm sure you've heard a lot about them this week, or if not at previous conferences, so I won't go too much into that. We've been an online payments provider since 2004, 2005. The high-level business goal there is the value we are offering to merchants is that through the simpler paying experiences for their customers, they would increase conversions. What we get out of it is that since we are actually extending the credit risk, so we do the invoicing. So unlike, say, a payment provider that is just built on top of a credit card system, where they're just trying to take a slice of the fees, we are actually extending the credit. So if they do not pay, the losses are on us. But if there is any interest to be earned on late things, or if they're on pay plans, then we take the profit for ourselves there. And we are in all the Nordics and Germany, Netherlands, and we moved into Austria last summer. So Klarna Engineering, we are young, attractive, and drink lots of Club Mate. The department as a whole has about 200 people. The main office is Stockholm. We also have sort of a Java big data shop in Uppsala and a sort of a Ruby on Rails GUI team in Tel Aviv. So the Stockholm office is probably the biggest Erlang shop outside of Ericsson. And just for some context in this story about this talk, 2-3 years ago there were about 10-20 developers, and then over the next 2-3 years it sort of has just exploded to over 60. So a lot of the challenges we face is going from a system where you have this core unit of people who are, pretty much salty, blue tail alums, going from lots of young junior people who don't know the system as well, who do not understand Erlang as well, and sort of just the adaptations we've had to deal with them just contributing to such a complicated system. The other factor that really complicates how development works at Klarna is that we are a financial company. We are pretty much a bank. In Sweden, I think there's 3 tiers on this, and we're just one level short. In Norway, we are a bank, and so we are subject to this Swedish financial regulatory authority. And so compliance is a big deal there. The live system is under a lot of scrutiny, and it's very important that any changes to the production business flows are documented, have business approval, and the code must be reviewed. So because of this, we want to have very, very strict control about anything that changes the behavior in the live system. So we can't accidentally release a change, or if some dependency implicitly changes, this could be potentially a very, very bad thing, or possibly even illegal. So you've probably heard a lot about our legacy system. So this is some core components of it, roughly unchanged from the system we've had since 2005. Just the nature of the company is when it was small, you have one production system, kind of, monitoring things takes, mental overhead, people, so anything we do, we just put it in here, and this sort of just grew and grew and grew. So 2 years ago, when the Fred work started, all the business functionality was not only running in pretty much this master-slave set of servers, but all the business logic was version controlled in the same repository, which actually had then just moved from Subversion to Git. And a lot of what's going on these days is to split these things out into independent services. So shiny new system, Fred. I hope some of you were at least at Mats Kronqvist's talk. So I won't go too much into the architecture of this. At a high level, though, it is a masterless distributed system running on top of riak, and it replicates data with the legacy system over a database abstraction layer built on top of RabbitMQ. So the main purpose of this is to be the termination point for our real-time eStore APIs. So eventually this will include the Klarna checkout, but the focus of the current ongoing work in this talk is about bringing over our legacy XML RPC API onto it. And so just a little bit about legacy business logic. So it's the case. So Klarna is different from a lot of software companies in that we do not sell software. We sell a service. So it's these APIs that eStores integrate against. So we are selling the fact that we service the API for their functionality. So that means we don't ship updates to users and expect them to upgrade their code. It's they're integrated against us, but they're expecting to call our web service. So we are in control of that. But one of the difficulties arises when we upgrade the entire system at once for everyone. And a lot of the history of the company is that to make those early sales that have allowed Klarna to double every year for the past 6 years, is that there's a lot of funny code in there for big eStores, and there's a lot of special cases, and there's just the little things where developer gets a fix-it ticket and he just hard codes that little thing. So there's a lot of these things, and a lot of this no one really understands why some of that is there anymore, or whether it's safe to remove that. And when you break something like this, it's potentially very, very expensive. You get a call, you get unhappy merchants. You may even have to settle with them if they lost volume because you broke something. So when the XML API breaks for a merchant, it is not just Klarna not taking those purchases for itself. It's actually, which is a fraction of the total ticket price. It is the entire ticket that the merchant loses. So it is very, very costly for us to break an existing integration. And so as part of this, we've had to refactor a lot of the system. So I'm not going to read this entire thing, but it's just a quote from a newsgroup thread with Linus Torvalds. And so the context here is there is some guy and his sound card driver or something breaks, and he just pokes at it, changes some magic number, and it works for him. He submits a patch. And Linus is like, what are you doing? Because it pretty much broke anything that was in this guy's system. And what really goes on here is just this development thing where this happens with a lot of inexperienced developers, where you have a problem and you just keep poking at it until it works for you, and it works for you, and you don't know what you break. But the fact is, when you're refactoring something that a lot of people rely on, there's really only two ways to do this right. One is to really understand the problem you are solving, think hard about it, and have a solution that actually works for this, or to use what people are using and not complaining about. And there's really no alternative. You either have to really know what problem you're solving and solve it, or don't mess with it, because it's just going to be expensive and costly if you're just twiddling around with this because you don't know better, or just for your own satisfaction. So the Fred work has actually gone under multiple migrations. The first one was actually just a big refactoring of the eStore API on the legacy system without any new servers or anything in place. And this is just to line things up such that it was even comprehensible to move things over. And the current work is actually moving more of that onto the new servers. And whenever you do any of this kind of work, migrations are dangerous. You are changing legacy business behavior that you are making a lot of money on for sort of the long-term benefit of the company. But if you didn't have any reason to do this, you would never want to touch this. The other issue is if you do too big of a change, you might have to run both versions at the same time. And when you have to move code to a new system while still running some version of this on the old one, the only real safe way to do this is to actually share the code in some repository that both systems can use as a dependency. Because if you copy and paste this from one to the other, it works just that day. And if any maintenance goes on for one of them and you don't remember to do it to the other side, then you could have some very, very bad production problems. So the entire continuous migration buzzword really is that we are iteratively growing the new system. It's even the old legacy crufty thing at Klarna has a weekly release cycle, which is extremely fast for any financial services company. And because of this, the sort of general pattern for much of the development is that the bits of business logic or functionality or even just useful utility code that was version controlled against this big, huge legacy repository is moved into submodules, subrepositories, which we update in the new system. So just for a line of code count, there's close to, I'm going to be a little rough here, but when we started, there's close to 500,000 million lines of code in legacy system cred. And in Fred, there is actually, after only about a year and a half development, there's actually about 500 million lines. 500,000, so about 500,000. So a huge chunk of this has been shared. And in order to make this work, and it's really, the fact is you're having the logic run in two places, but they're actually somewhat different systems. You need to reorganize just the legacy code, which, when you version control everything in one place, your dependencies get really intertangled into just a system or a family of software artifacts that allow you to compose these things better. One of the keys to doing this is using frameworks. So I'm using this in a very, very general sense in that I will call framework any kind of code where you hand it a callback module. You hand it code that it calls back, as opposed to, say, some big system platform framework where you just... so I don't mean framework in the Rails sense. I mean framework in more of the Gen server, Erlang supervisor sense, where it's this small little utility where you give it a callback and it handles the boring details of the control flow or managing certain resources, and the callback is where the interesting logical bits happen. Using frameworks, just shared libraries, so there's two kinds, where there's business-specific ones and business not-specific ones, and then there's the system-specific code, and then this last thing, which I'll just call stubs, which is stuff where it's not really quite implemented on the new system. So frameworks. So this is sort of, once again, the Hollywood model, where you are not calling the framework from the application, the control flow. You are giving it something, and it calls your callback. And for something where you really need to separate the concerns of what is important in terms of the flow of things versus what is system-specific or what is sort of instance-specific, it's extremely important to sort of divide this up. And these are actually things that once you appreciate how the control flow goes, it's actually very nice to program against, because new instances, new features are often just a new callback instead of having to do that unpleasant thing where you kind of feel, I'm sort of copying the control flow here and it's not quite right. And the nice thing about frameworks is they're sort of usually general enough that you don't really need to change them. If they work for the sort of initial general case, they tend to work for 90% of the instances. And like a good framework, if you have the right interface there, it's really hard to actually get it wrong if it works for sort of the common case. So the shared libraries, amongst this is actually also code we just get off the internet from GitHub. We use quite a bit of Basho stuff like Web Machine and Logger. We use MochiWeb, a few of the folsom things from Boundary. We have some of our own internal, like just system generic things, like the Tulib library, which is just sort of general libraries for things that perhaps should be in something like the OTP standard library but aren't. Then you have some funny things like just weird legacy-specific business definitions. So this example here, currency, I think we've added some actual APIs, but initially this thing was just, you could go to integration.klarna.com, you see that we have this funny quirk where currency codes on our API don't correspond to any real standard. It's just sort of an incrementing up of currencies as Klarna has supported new ones. So the Swedish crown is 0 or 1 or something like that, and then the Norwegian crown. And it's a sad thing, and it's something we'd like to get rid of. But we have 15, 20,000 e-stores integrated against this, and as we have new systems, they still need to understand this definition. And yes, it's only 5 defines or something like that, and you could just copy it over, but that would be wrong. And you really want to be able to share the definition, and it's this, and it's rather tiny and pure, but it happens to actually exist both in FRED, in CRED, and in the new implementation of the payment termination for credit cards. Then there are other sort of more pure business libraries where they have some Klarna business logic in there. They're not, nothing we'd ever want to open source, but they're still general, and they still give the business meaning to how Klarna interprets things. So this example here is for the Swedish, not just Swedish, but what Klarna thinks of as a person number. So if you're Swedish, you know that this is a rather sort of fundamental part of how you interact with Swedish customers. Due to our legacy, this is somewhat overloaded for other contexts, and so this is the Klarna-specific meaning for what we think of as person numbers, and this logically has to be shared between the old system and the new system, so it's in there. And then another sort of style library is something where it's not really a library in itself, it's more of a family of callbacks, because when you use these frameworks, you have these callbacks and you want to just share the definition. So this one thing, RPC API FE, it's really just the definitions for the types for our XML RPC API, and also the method specifications. And so the ones we want to share between the systems, we put in this separate repository. The other thing is system-specific code. Some of it's awesome, some of it's terrible. So you can consider sort of anything in the old thing that no one's really looked at much or thought much about. That's sort of CRED-specific, system-specific. Database clients. So the legacy system has this replication layer on top of Amnesia. Then the FRED system uses riak, and we have some client layers on top of that. The logging and monitoring is sort of system-specific, and sort of to make this work out nice, the way you want to actually do this is your frameworks should orchestrate the general things. And for the bits where you have to call system-specific things, you give them the system-specific callback. And then there is sort of the stub. So on the new system, where maybe you haven't entirely refactored out all your dependencies into some nice place to put it and call it, you just sort of punt. So the nice thing about, the quote-unquote nice thing about Erlang is that if your module just says, I'm going to call this function in that module, and you want to move, and this is moved around, and the other system, it really just needs some module with a function of the same arity. And so we are kind of exploiting this to just say, okay, well, this super CRED-specific call, we don't actually need to do it. Maybe it's only done on CRED for side effects. So on FRED, here's this wrapper implementation, and it just returns okay. So obviously this is technical debt where we are putting off actually figuring this out and cleaning that up for just having this little wrapper and it's fast. But the one advantage of this is actually a version controlled to-do list. Every function in one of these stubs, at some point in time, someone is going to at least want to get rid of these. So at least it makes it very, very clear what is not on the other system, what doesn't have a real implementation. Okay, and the way this really goes, because FRED, we are not actually it's not a new product in that we're not selling any new API calls. It is the same old legacy API we've done before, but it's a massive change in how this is implemented. And so there's a couple standard terms for how this goes. So one is sort of the Theseus thing, which is this sort of this Greek paradox where you have this ship and it goes on this long voyage, and you just have to repair it. You have to replace the boards, and you've changed everything. And by the time this ship ends its journey, every piece of wood in this thing has been replaced twice. So is it still the same ship? It acts like the same ship, but it's not really. So everything has changed, but there's a certain sense where this is the same thing. Another version of this is the grandfather's axe, where this is my grandfather's axe. The head has been changed twice, and the handle has been changed 3 times. This is my grandfather's axe. And it's that it spiritually is the same thing. It does the same thing, but you may have changed every component in there 2 or 3 times. And this is how much of the code migration has gone. We've refactored many of these multiple times. Functionally, it's still supposed to do the same thing. The way it's organized actually looks much, much better. But in a certain sense, this is both completely different, but it's also the same. And in particular, it must be the same to the outside world. And so having these shared dependencies is extremely important for this, because you clean things up, you move it into the shared place, and then it's there, and then the work goes into both places. So for the cases where we are actually able to share the dependency, this works out rather nicely because anything you move from the legacy system into a shared place is business value, which you presumably could share into any new systems, perhaps ones we haven't even thought of yet, and also any maintenance if someone needs a new feature, just extend something. If it goes into the shared place, any system using that library gets the advantage of that, whereas if you had a forked version, then you have to do the maintenance multiple times, or you might even forget in one place and bad things would happen. So because of these dependencies, we run into just the source control problem of, well, you have the system, it has many sub-dependencies, so Subversion has something called subtrees, and how do we manage this? For legacy reasons, because the old system is not completely moved on to rebar dependencies, but it does have dependencies that build with rebar. That is actually using Git submodules. And for the new system, Fred, it is using rebar configurations. And one nice thing about Fred is actually the top level repository is actually just test cases, a rebar config, and build-in configuration settings. So there's no actual business logic at the top level thing. It really is just, the most important thing there is the rebar config, and there's nothing in there directly about how Klarna does anything. It's all in these sub-dependencies. CRED uses Git submodules. I don't know if you've used them or not. They are sort of a funny feature in that the developer experience with them is extremely unpleasant. The commits messages and diffs are totally non-intuitive and not useful because it's really, you are just updating the SHA-1 references, and so it's not exactly what you want. Developers prefer to think about these terms preferably in branches. If it was up to everyone, they would just track master and everything would just work out nicely. Or short of that, like some kind of tag, or at least something with a name. Whereas Git submodules, it's just these SHA-1 hashes. The one advantage of them is that they're extremely consistent and predictable. As long as you understand what they're really doing, which is they're just concrete pointers, they're at least predictable. So they have that little advantage, but in general, I think if at all possible, you do not actually want to use Git submodules for anything. Fred, new system, and all other new systems, new Erlang systems at Klarna, uses rebar for dependency management, sort of. But we've actually had to flatten our rebar configuration file, and the top level builds with a patched rebar to not recursively look into the dependencies. And this is just because, I remember at last year's UC, Dave Smith asked, has anyone run into issues here? And so I think for the general simple case where where your project might only have 4 or 5 dependencies, it's not so bad. The likelihood of you having nested dependencies is sort of low, and you might do things like jigger around the order, and then you get a relatively consistent thing. For us, we have close to 100 dependencies in there, most of whom, if you actually were to flesh things out, would have rather nested dependencies, and they're not always updated in tandem, and it's actually not a tractable thing to update everything. So if you have a low-level dependency and everything that uses it, if you were to bump everything that uses it, you would just have these trivial changes for, say, a minor revision. So you can't really have everything up to date with these. Fred uses a flattened one, and our patch gives us this rather unfortunate thing where it's rebar, get my dependencies, but do not recursively do this. So it's sort of, just unfortunate wording. The more we go through this, we've kind of worked around this, and everyone I've asked about this says, we just have some way to make it work. I think Campania, they just are really good about lining things up to make sure that they don't really get hosed, but every now and then they get a little surprised. I talked to Jared at Bastro about this, and he's like, yeah, when we get close to release candidate, people sort of freeze things, but secretly I'm running this shell script that takes the SHA of everything, and if a dependency changes, I get really mad. We don't do this. We just keep everything pointed at tags at the top, and it's a little painful, it's more work, but we at least get a consistent result from doing this. So more to that. Developers would love to just be able to track master. It would be so nice if you just were to track master, you get the updates from the outside world. I don't know how many times I've heard master should just always work, but it doesn't. Master will break. If you're tracking a branch and someone from the outside world changed the branch, you will get screwed, especially if you're tracking, say, the GitHub master. You don't know why anyone, they could have completely refactored something, they could have broken backward compatibility, and the right thing to do that is, but it's in the main system, they will ship to master. You do a fresh clone, you haven't changed anything. You might not have changed anything in a week, but your system stops working. If you want any kind of reproducibility, tracking a branch is bad. So for a while, so for our rebar config, we switched to tracking just tags quite some time ago. In one of our test suites, we actually were just downloading riak, building it from source, and we realized, we kind of don't want this moving target riak, so we're going to track a tag on that. But we actually got screwed by that too, because so we get this tag version of rebar, but it's tracking the masters of its stuff. So our build breaks, and we actually can't even reproduce it because we don't know what rebar master would have built for us yesterday. So our problem is a little different from companies that are a bit more open source in that the requirements for strictly knowing what goes out are, so we have much stronger requirements for this, and also there are a lot of companies where they only need things to work before they package something they sell to someone. So things only need to work then. Whereas for us, we release on a very, very high rate, and our things need to constantly work. So tracking moving targets and letting these changes implicitly happen is very, very bad. So if you're in this situation where you really need to strictly control what is actually going out, tracking a branch is going to burn you eventually. So we use tags internally. We try to have everything semantic versioned, semver.org, and so this is just a standard 3, sometimes 4 number version. So major, minor, patch, and at the high level, a major change means you have broken backward compatibility in some way. Minor means, well, this API has been extended, but everything that was exposed previously is still there and should behave the same. And patch is, well, we fixed a bug and there are no interface changes. And so one thing is, so everyone knows this, everyone's read this, everyone heard it, but I think in general people are actually rather afraid to commit to actually tagging things appropriately. The Semver standard actually has this clause where, and you kind of heard this in the Elixir talk earlier, Dave, you read it. It's like, before you go 1.0, it means nothing. So you can break backward compatibility all you want. And so just never go 1.0. And we actually have started to just, as soon as you've done something internally, just go to 1.0. You want to, you want to be able to have the ability to bump your major version, because your major version going up tells the rest of the world, hey, hello, if you use me and you update, check that nothing's broken, because something might be deleted, something might be gone. See how the interfaces change. Or even minors, and even within Klarna, it's somewhat inconsistent. I've seen people tag huge backward compatibility things as a patch, and it's, if anything, just a lack of confidence for saying this is actually a major change, or I'm not ready for this to be 1.0. And so for a product you sell to the outside world, yes, your business people probably care that you're running, that you've gone from Java 1.5 to Java 6. It's cool to go up your major. You want to say you can sell it, or the way it's like you don't want to have committed to a big change. But for just an internal software dependency, you should not have an emotional attachment to any of these version numbers. If you've broken backward compatibility, bump your major, because your users will want to know that. So testing, we have a fairly standard setup. We will rely on Jenkins for just our standard continuous integration. Testing, we use both eUnit and common test. So there's also this new sort of mode of use of eUnit called common eUnit, which is just a parse transform that allows you to write test cases that look like common test cases, but run as eUnit or under eUnit. And so you get the advantages of your tests have the nice setup and breakdown in the common test style, but you get the speed of eUnit, and there's also some use of proper. So something a bit more experimental going on, but rather important, is our system verification tests. So for Klarna, this is something new because previously we have one system. It has its test suite. It doesn't really care about anything else because it doesn't interact with any other internal systems in any way. Whereas now that we have both CRED and FRED and Rabbit brokers in between, and the FREDs running on Riak nodes, which aren't necessarily in the same VM, there's a lot of different agents going on, and we would like, and so we want to integration test how these go. So this is the system verification tests. Right now, it has sort of two modes of use. One is the single developer setup, where it just fetches everything and tries to run it on one place, but it's configurable enough that it can run on multiple hosts. And there's a lot of ongoing work to be able to do nice things like spin up a bunch of virtual machines, have everything just set up for you, run your test cases against whatever this is, and then report back your results on Jenkins. So hopefully we'll have a nice EUC talk next year when this is a bit more mature. So right now, FRED is actually in a beta state. We are continuously on. We are taking traffic right now. All of Klarna's XML RPC traffic goes through the FRED machines, and for the call that it can handle, which is this identification called get addresses, it services that completely, except for a few cases that we still proxy on, and we are planning on rolling out the purchase taking capabilities in our reserve amount and add invoice functions over the fall and winter. So right now, FRED is currently developer operated. So we've been in production full time for about 2 months now. And so right now it's a rotation of 4 people. We're adding a few after the summer. And yeah, so the buzzword for this is Devops. I don't actually know what that really means, but it's developer operated. And so my teammate Malcolm likes to tell this anecdote about these helicopters in the Vietnam War, where they were having lots of problems. They would have mechanical problems when they're on missions and stuff. And then some genius general realized, well, we'll just put the mechanics in the helicopter, and suddenly they became magically much more reliable. Another way to look at this is this observation by James Hamilton, where if you have operations people responsible for a big problem, you end up getting a lot more operations people. They will just hire more operators. Whereas when you have developers throwing out a problem, they end up automating a lot more stuff. And so in this standard DevOpsy thing, we do our configuration management in Chef, which is a standard tool. So it's written in Ruby. Sort of the other big alternatives to this are Puppet and Ansible. So Chef, we more or less inherited. And so our production servers for all the new things are configured and managed with Chef. So this is the FRED Riak nodes, the RabbitMQ servers. We also use the Chef cookbooks to bring up these testing machines in the appropriate configurations. So this is a bit different from the previous model where, someone installs the system on some server, they compile the code on that one by hand, do a hot code load to upgrade it, and if they ever need to make another one or to replace the machine, you gotta hope the last guy who did that is still at the company. So this internally, we have developed this tool called Ergonaut. There's some relationship between this and rebar overlays, and also this library used in some of the Basho Chef cookbooks called the Erlang term helper. And it's so these configuration management systems, most of them are Ruby. So Chef and Puppet are Ruby. And they have this notion where any configuration file that you might want to go out with your system, you should have some template in there, and it is generated as part of your recipe. And this is a relatively nice standard thing for Riak because their sysconfig changes very rarely. This is sort of appropriate, but for something like FRED, where we are making things highly configurable, just as a matter of practice, our sysconfig grows weekly. And if you have a template in your Chef cookbook, which is separate from your main code base, you have to do a lot of work to make sure they stay in sync with each other, because here's the official thing, well, here's the one where your developers are having the defaults. here is the one where your cookbook is generating this file, and if you add something to the one with the source, then you need to remember to put the defaults and the values into the cookbook template. And for us, we found this to be rather just intractable, because it meant for most updates to Fred that we wanted to release, we would have to make a cookbook change just to add some defaults. So Ergonaut is this little tool where it's rather general. You give it a JSON, and the keys are Erlang, it's so just nested structs, and the keys and values are Erlang terms, and this sort of translates out into things you would like to override or delete in something that looks like an Erlang sysconfig. So as a result of this, we have a minimal number of cookbook changes. So now our cookbook only changes when things about how we deploy are changed, as opposed to having to add these defaults to it every time we want to roll out a new release. So deployment, Fred and Cred are both able to handle XMR RPC traffic. In most situations, the functionality that Fred cannot handle is proxied to Cred, and so we have a load balancer in front of this guy, so if, say, Fred needs to go down for maintenance, we can still just send everything to the old system. So Freds are upgraded independently of the legacy system. It happens multiple times a week, and so we are actually not using RelUp or anything like that. They are independent and stateless enough that when we want to upgrade them, we just take down the VM and then start a new version of the code. Okay, I'm actually just going to talk about frameworks some more, because they're pretty awesome, and it actually goes a lot towards the fact that when you have developers also doing the operations, they do a lot of stuff to just be lazy about things. The real point here is, I think, when you have frameworks, it really gives you the ability to add new bits of functionality or just the common call patterns with a lot of ease. So I think one of the most important frameworks that's really made this migration possible is Soapbox. This is on our GitHub, and this is the framework we've used to re-implement our RPC API. And at a high level, it's got two things. One is the Soapbox types, which are somewhat general. It's a way of just specifying little input validators for things. And then there's the Soapbox methods, which is really multiple callbacks for separating, checking your arguments and converting them versus actually taking the call on the converted arguments. You keep hearing about how Klarna, how we are taking the call on Fred and just deciding whether or not we can take it. A lot of this is based on Soapbox method routing. It is implemented with a parameterized module. And so it's at a high level where, it's a really basic combinator. It's that here's a callback. So here's the behavior. You specify implementation for how you type check the thing and how you do the call. And say you have two implementations and you want to decide which one you use. So really, there are just three inputs to this thing. You have one implementation, the other implementation, and something that decides how you go in between the two. And because the Soapbox interface is all these, a method is a callback, which is a module, then having a parameterized module where you take two of these and the routing logic and gives you a module with the same interface is the natural way to do this. It's about 15 lines of code, works perfectly. So using this, we have what's called the Fred custom routing. And what this is that using some more parameterized modules, we take the call, we parse it and type and check the types of the inputs on Fred, and then we actually inspect them. So for get addresses, there's certain corner cases which have not been ported over to the new system yet, and based on whether we know Fred can handle this or not on the inputs, we either take it locally on Fred or proxy it to Cred. And so there's actually theoretically several thousands of permutations we can do this on, and using several layers of parameterized modules, it's actually very little code. So another nice framework we have is our Logger Smtp backend. This is a little different from the one out in the wild on GitHub. So Logger itself is the backend. So Gen events is it's a framework. You give it event handlers. And so what we like about ours is that the SMTP backend itself just specifies taking this log message and sending it out to this Gen SMTP implementation. So the details of who the message is from to subject and body are all in a callback. So there's a dummy one which really sends it nowhere, but it's this notion that, well, how the user of this wants to format their subjects, how they want to format their error emails is probably up to them. The fact that they want to take a log message and send an email is a rather general concern, but how they format these things is system specific. So the details of that should not be part of the mail alarm implementation, but there should be a hook to be able to provide this in. And actually, someone in Klarna thought this was a pretty reasonable idea for his system, forked it, modified it a little, and it's roughly the same principle, but for SMS backends. So in this, the 160 character message and the recipients are specified by a callback. Sort of a more general thing where we love callbacks so much we pass callbacks to our callbacks. Is our rate limiter backend. So this is sort of a generic rate limiter for Logger backends, and you can install something and have different rate limiting based on severity. And it's general enough that we can use multiple versions of this instance of this in the same system. So Fred currently uses the rate limiter backend twice, once for SMSs and once for emails. And so here's another, this is kind of the craziest Logger backend we have. I don't even think half the Klarna developers know about this one. It is so we have these message brokers anyway. One of our backends is to send the log messages over the message broker. So officially we are using this very nice paid solution called Splunk for aggregating the logs. But there's certain instances where you really just want to log into a machine and tail your logs for all 5 of them that are running, or however many. And there's certain Logger backends where you want to evaluate them, but you really don't actually want to install them in your production machines. So we have this separate thing, and this sort of relies on the fact that there's a nice ADT for the notion of a Logger message, and it just sends the message over the message queue instead of some serialization of it. And on the other end, we just gen event notify this to a Logger running there, so we can use Logger backends. So the Logger message is generated on on the actual Fred nodes, but there's a handler for them on an entirely independent system. That's it. And this is everyone who has ever made a commit on Fredmaster. So, questions?
Thank you, Daniel.
Thank you.